In this short video, you will learn how sparkling beverages are created in our R&D laboratories and produced through our bottling partners. As the largest global beverage company, the Coca-Cola Company's sparkling beverages, which include flagship brands such as Coca-Cola, Sprite, and Fanta, are developed through our concentrate business model through our vast bottling system. Ideas can come from anywhere, and during each stage of a project, these special ideas that meet consumer needs and contain a value-added business case are taken through a project decision-making process based on viable results. Within the Coca-Cola Company, a typical decision-making process is called a stage gate. A stage gate process typically contains 5 gates. 1. Discovery. 2. Business case build. 3. Development. 4. Market launch. 5. Post-launch review. Research and development is part of each of the 5 gates. To illustrate a typical stage gate, let's first meet Emma. Emma is a product development manager for the North America business unit. Working with her marketing and business partners, she has created a winning concept in a consumer test. Ready to enter Gate 2, the concept's business case build, Emma has designated the following product design requirements based on consumer feedback, including watermelon flavored and natural flavors, 100 calories, 12 fluid ounce serving, low carbonation, pink product coloring, suitable for USA and Canada, packaged in clear 20 fluid ounce plastic bottles and 12 fluid ounce cans, meets bottling system requirements. Now she is ready to move on to Gate 3, development, to prepare for a summer launch in the US and Canada. Planning is the first step. As Emma works through the project plan, she knows to consult key partners in the product development process. These are regulatory partners, internal and external flavor experts, the concentrate product supply, CPS, and the bottling system, which is consulted in order to create a product design ready for the system in place. Every country has different ingredient and food regulations. In order to be sold commercially in the US and Canada, ingredient and ingredient levels need to comply with local food laws. Ingredients such as flavoring need to be evaluated so that they can be used at the intended level within a product category or with the intended claim. In Emma's case, the product design brief requirement is a claim for natural flavors in the US and Canada. Sparkling beverages are considered high-acid products, that is, products defined as having a pH of less than or equal to 4.6. In addition to containing treated carbonated water, most carbonated beverages within this category contain the following ingredients: sweetener to add sweet taste, flavor, and body. These can either be nutritive sweetener, such as granulated sugar or high fructose corn syrup, or low-calorie, high-intensity sweetener, such as aspartame, asulfame K, or stevia. Acidulant, such as citric acid, malic acid, or phosphoric acid, to balance the beverage taste, provide additional flavors, and to reduce the pH. Natural, artificial, or nature-identical flavorings that provide characteristic flavors, such as watermelon. Colorants, such as naturals, dyes, and lakes, to provide consumer relatability and preferred appearance to a flavor. And sometimes chemical preservatives like sodium benzoate, potassium sorbate, or EDTA to provide shelf stability. In some cases, the pH of the beverage is low enough to provide shelf stability without the need for chemical preservatives. Using this basic formula, innumerable different sparkling formulations are possible, and by carefully controlling the water amount, different forms of products are possible as well. There are several different forms of sparkling products in our system. For example, post-mix syrup, or POM, that are used in customer locations such as restaurants. Carbonation is a key ingredient for a sparkling product. Typical carbonation beverage levels range from 2.5 to 3.8 volumes of CO2. In general, full-calorie colas and Sprite are at 3.8 volumes of CO2, while Fanta is at 2.8 volumes of CO2 due to consumer preferences. Diet or light products are carbonated at 3.5 volumes of CO2, less than full-calorie products because some low-calorie sweeteners are prone to foaming, even more so when combined with carbonation, which can make it very difficult to fill efficiently on our bottling filling lines. While taking into account basic formulation principles along with a regulatory assessment, Emma has now developed several formulations. After finding successful consumer test results for one formulation, her team is ready to commercialize the product. Our concentrate product supply is our core business model, which creates and delivers modular recipe kits. Each kit contains two components, dry parts and liquid parts, which go to our system bottlers. These recipe kits, combined with the sweetener and carbonated water our bottlers provide, are used in order to deliver the same great-tasting beverage every time. It is through our CPS locations that we are able to provide ready access to recipe kits for our system bottlers. Emma must now take her lab formulation and convert it to CPS requirements, taking care to ensure she meets the following criteria. Must be from Coca-Cola approved ingredients. Must meet microbiological risk requirements. Must not cause caking or ingredient stability issues. Must fit available packaging options for liquid products, that is, flavoring concentrates. Must have Department of Transportation classification, such as hazardous or corrosive labeling, in order to ship. As part of formula due diligence, Emma creates laboratory products for stability evaluation. This is in order to provide a shelf life recommendation for both the concentrate parts as well as the finished beverage based on typical storage. The product stability assessment is comprised of both sensory and physical components. First, Emma will assess flavor part stability. Second, assessing CO2 retention and chemical stability of the beverage and diluted concentrate parts, such as byproducts from ingredient and processing based on historical standards of like products. And third, Emma works with the analytical department in order to assess samples of the new flavor part or parts for government transportation classification, allowing for proper handling during distribution. As part of the stability assessment, packaging materials such as PET or can liners in contact with a beverage and/or concentrate are verified low risk through a regulatory and quality evaluation. This is necessary because packaging materials can alter a formula through flavor scalping, off-notes through packaging migration, or chemical interactions between the formulation and packaging materials. Cans, in particular, are sensitive to corrosion, and some formulations, especially ones containing high levels of artificial red colorants. The type of packaging can also determine shelf life. For example, PET or plastic packaging will often lose CO2 pressure over time. This packaging will have much lower shelf life for the same product formulation than a can or glass package, and if not assessed, can lead to an unacceptable consumer experience. Also, part of the formula due diligence process to validate the scale-up of a laboratory formula, a pilot plant or bottler plant run is analyzed. During the manufacturing run, mixing and processing parameters are evaluated to assure flawless execution. These beverage samples are often used for business teams to communicate the upcoming new product with customers. The final step of the commercial preparation process is to officially document the formulation within Picasso, a specification repository for the company. Formulas are given a unique BBN, or beverage base number, within Picasso. Formulations go through multiple levels of approvals, including ingredient approvals for all new ingredients and/or vendors in the system, nutrition and claim validation, product formulation approval, manufacturing instructions, and specific country for sale. Within Picasso, the formulation is written as a ratio of carbonated water to syrup. The syrup formulation consists of all the other ingredients, including the sweetener, while leaving out the majority of the beverage water. Typical throws for carbonated beverages are 5.5 to 1, 5.4 to 1, or 5 to 1. Once the formulation has been approved within the Picasso specification system, it is considered a master formula and can be produced commercially and sold in the countries in which it is approved. The master formula consists of globally applicable manufacturing instructions. As each bottling plant may be unique, master mixing instructions are derived from Picasso and tailored to fit local manufacturing facilities. Often, this may convert the standard dry sucrose in the master formulation with a local sweetener, such as high fructose corn syrup. Formulations are often reassessed after a commercial production run, especially evaluating its sensory and stability characteristics to validate quality and confidence to reapply formulations. Emma's product was a success in the market. Now, using the exact steps outlined, Emma's Coca-Cola beverage product can be reproduced time after time in our 1,000+ system bottlers around the world every day.